All right, this is sections 12.2 and 12.4 notes. We're going to talk about area and volume of prisms and cylinders. A prism is a polyhedron with two bases, they're congruent bases, that lie in parallel planes. So this first example we're going to look at is a triangular prism. And what I highlighted here are the base. So the base here for this triangular prism is a triangle. And if you recall, last time we talked about the prisms being named by the shape of their base. So the shape of their base is how we classify and name prisms. Okay, so this is just the net of a triangular prism. You can see that the other three sides are rectangles, and that's how we know the faces. Create the prism. Okay. Now there's two types of different prisms. We can have a prism that slants and is not perpendicular to the base, and we call that an oblique prism. Or we can have a prism where it's straight up and down and is perpendicular to the base. Then we call it a right prism. And we'll look at some examples here of what a right prism is and what an oblique prism looks like. Okay. A cylinder, let's talk about a cylinder. A cylinder is a solid with congruent circular bases that are parallel. So here's your general cylinder, here's the base. Right, these are parallel and circular. Okay. Here would be the outline of the net of a cylinder. Right, so if you were to fold this all up, you'd have a cylinder. So this is the net of a cylinder. Oops, net of. Let's take that back and write just net of a cylinder. Now to classify each solid, the very first one, do you see how it's slanting? And if I were to draw down a right angle, the height does not meet at a right angle unless I draw it in. So this makes this an oblique triangular prism. Part B, this does meet at a right angle, so all the faces, if I were to draw in the height, I could easily find the height just by looking at it. I wouldn't have to draw it in. This is a right hexagonal prism. All right, so both C and D are going to be oblique. D is unique because it is a cylinder, so this will be an oblique. Cylinder. And C will be an oblique pentagonal, because our bases are pentagons. So I'm going to color in the base. All right. Now let's take a look at what formulas we need to have memorized in order to find surface area and volume. So for surface area and volume is this whole unit. So let's look at the formulas. Must memorize these. So the lateral area for either the volume for the prism or a cylinder will be the perimeter times the height. Now keep in mind, if it is a cylinder, the perimeter is really the circumference. Okay, so lateral area and surface area, write yourself a note. This will be measured in square units. Volume is cubic units. And the surface area equation be the lateral area, where you can abbreviate it LA or L, plus 2 times the area of the base, because we have 2 bases. So really these formulas come from, if you were to look at a net, what would the net unfold? So if I substitute the perimeter times the height in for lateral area, plus 2 times the area of the base, that would give us the surface area. So for each example, these are the things we need to find in order to find the volume, or the surface area, or the lateral area. We need to find P, capital P, the perimeter of the base. H would be the height from base to base. And capital B, we say, is the area of the base. Area of base. So our volume equation will be the area of the base times the height. Okay, so for each one of these, you always want to identify what exactly your base is first. All right, then we can kind of go through the perimeter, height, and area of the base. So this first one says find the surface area and volume of a rectangular prism with a length of 12 centimeters, width of 10, and height of 7. So length would be 12 centimeters, width we have 10 centimeters, and height we get is 7 centimeters. So what is our base? Our base is a rectangle. So let's go through each one of these because we need to find these first before we find the lateral area and volume, and then surface area. So the perimeter, if we look at the perimeter of the base, it's a rectangle, so it'll be 2 times the length plus 2 times the width. So 2 times 10 plus 2 times 12, and we get 44 centimeters. The height is given to us as 7 centimeters. And then let's find the area of the base. So the area of the base, since it's a rectangle, it's just base times height. So we get 12 times 10, which is 120 centimeters squared. All right, now let's find the surface area. So our surface area equation, as you see up here, is the lateral area plus 2 times the base, or in other words, the perimeter times the height plus 2 times the base. Okay. So we have our perimeter is 44. Our height is 7, and our base is 120. All right, and when I simplify, I get 308 plus 240. So our surface area is a total of 548. Now units, because it's area, is centimeters squared. All right, let's look at the volume. Okay, the volume is the area of the base times the height. So you already know the area of the base is 120, and then our height given is 7. So we get 840 centimeters cubed. All right. Let's look at our next example, number 2. So 2, we're just looking at surface area for both these two shapes. So the first one is also a, like our beginning example, a triangular prism. So here's my base. Okay. Now it's unique because it's an isosceles triangle. So base is a triangle. Okay. Well, now let's find our perimeter. So our perimeter for a triangle, since they're all the same sides, is 6. So 6 times 3 is 18 inches. The height, so the height of our prism is 8 inches. So from base to base is 8 inches. And then the area of the base is what we need to find next. Okay, so I'm going to redraw this triangle a little bit so I can mark it. So I know it's an equilateral triangle. I do need to find the height of this triangle in order to find the area, right? So if this is 6 and I break this down, this would be 3. Okay. Now remember, all equilateral triangles have congruent angles, so this would be 60, which makes this a 30, 60, 90 triangle. That means my height would be 3 square roots of 3. So to find the area of the base, I'm going to take 1/2 of the base shape. So 1/2 of 6 times 3 square roots of 3. Okay, and that gives me 3 times 6 is 18. Half of 18 is 9, so 9 square roots of 3 inches squared. All right, so since it's asking for surface area, which is the perimeter times the height plus 2 times the area of the base, we take 18 times 8 plus 2 times area of the base, which is 9 square roots of 3. And let's go ahead and leave this one in an exact form. So we will have 8 times 18 is 144 plus 18 square roots of 3 inches squared. So this entire thing, since it has to be an exact form, is our answer. So 144 plus 18 square roots of 3 inches squared. All right, let's look at this triangle. So the base is a triangle. So we can actually find the perimeter. Now notice here, if this is my base, I'm missing one part to find the perimeter, and that would be the hypotenuse. So you guys, you can use Pythagorean theorem to find the hypotenuse, but recognize this is a Pythagorean triple, so this length is 13. So my perimeter of the base is 5 plus 12 plus 13, which is 30 inches. The height, you guys, is given to us, so h is equal to 9 inches. Now we have to worry about the area of the base. Since it's a triangle, it's 1/2. 12 times 5. So 12 times 5 is 60. Half of 60 is 30, so we get 30 inches squared. Okay. All right, so our surface area, perimeter times height plus 2 times the area of the base, is 30 times 9 plus 2 times 30. And I get 330 inches squared. All right. So now let's look at this next part here, which is a trapezoidal prism. So I'm going to redraw the trapezoid just to make sure I have all the parts that I need. It's not an isosceles trapezoid, notice, because this has 8 inches. This side is 7 inches. And this side says 9. So it's not isosceles. And the base is 12. And the height of our trapezoid is given to us by this 6 inches here. So this would be 6 inches for the height. Okay. All right, so we need to find lateral area and surface area. But let's start with our perimeter. Now you guys, I've been writing, as you noticed, surface area, the formula each time. If you do that on your homework consistently, you're going to have it memorized. All right, so the perimeter of our base would be 12 plus 9 plus 7 plus 8. So since it's a trapezoidal prism, we identified the base is a trapezoid. And our perimeter is 36 inches. The height given to us from base to base is 10 inches. And then the area of the base, since it's a trapezoid, remember The area formula of a trapezoid is 1/2 base 1 plus base 2 times the height. So 1/2 base 1 is 8, base 2 is 12, times the height would be 6. Okay, so let's find the area of the base. And I get 60 inches squared. All right, so lateral area is the perimeter times the height. So 36 times 10 is 360 inches squared. Now the surface area is the lateral area plus 2 times the area of the base. So we already found the lateral area to be 360. And the area of the base is 60, so 2 times 60. So 360 plus 120 is 480, oops, not 88, 80 inches squared. Okay. All right, we have a couple more examples to go through for cylinders and hexagonal prism. All right, so for a cylinder, the height, this one's actually asking you to find the height given the fact that we are given the surface area of 198.8 square millimeters. Okay, so the perimeter, again, you guys, because it's a cylinder, the perimeter is really the circumference. Because we are working with a base that is a circle. Okay, so perimeter is 2 pi r, and our radius is 2.8, so 2.8. And let's go ahead and multiply this out. We get 17.59 for the perimeter. The height we don't know, so we're trying to find the height. The area of the base, because it is a circle, is pi r squared. So let's go ahead and multiply this out. Pi times 2.8 squared. And let's go out 2 decimal places, so 24.63 millimeters squared. I forgot my millimeters up here. Okay, so then for surface area, since we're given that, let's go ahead and write out our equation. 198.8, I'm going to sub that in for the surface area. Perimeter, we have 17.59. Height is our big mystery. And the base, we have 24.63. Okay. All right, and we are just solving from here for height. Okay, so I have 198.8 is equal to 17.59 h plus 49.26. So if I subtract 49.26 from both sides, it's just algebra from here. So I get 149.54 is equal to 17.59 times the height divided by 17.9, and we get our magic number for the height. Height is 8.50 millimeters. Okay. All right, next one. number 5, we're finding the exact lateral area, surface area, and the volume for this cylinder. So notice in the cylinder we're given the diameter. Let's go ahead and mark that radius. So the radius is going to be 5. So our perimeter, which is our circumference, 2 pi r, so 2 pi times 5 would be 10 pi feet. The height is 8 feet. That's given us, so base to base. And the area of the base, pi r squared, because it's a circle, pi times 5 squared would be 25 pi. Okay, so keyword exact here. So lateral area is the perimeter times the height. So we're going to take 10 pi times 8. So that just means if I want the exact value, I want my answer to be in terms of pi. So it's going to be 80 pi feet squared. Right, so there's our lateral area. Let's find the surface area, which we know is the lateral area plus 2 times the area of the base. So 80 pi plus 2 times 25 pi gives me 80 plus 50, which is 130 pi feet squared. Okay, and then we need to find the volume. So the volume is area of the base times the height. We have area of the base is 25 pi, the height is 8, so 8 times 25 is 200 pi feet squared. Now when you guys are looking at your homework, please don't forget to write in pi. It's not 200 feet squared, it's 200 pi feet squared. Okay. Alright, number 6. All we have to do on this one is find the volume, but the volume requires the area of the base and the height. So let's write down what we're given. So we're given each base edge is 4 feet, and the height from base to base is 10 feet. So let's write down our perimeter. Perimeter, we'd get 6 sides, all the same. 4 times 6 is 24. Our height, which is given, is 10 feet. And this is where we need to find the base. Alright, so if you guys remember from chapter 11, we had to use the apothem on regular polygons. So that's what we're going to do here to find the area of the base. So I'm going to go ahead and draw out this triangle again. Draw it a little bit bigger so I can see what I'm doing. Okay, I'll zoom in here a little bit for you. Alright, so the area of my base is, sorry, not area of the base, that's what we're trying to find. If this is 4 and I draw in my apothem, this is 2 and this is 2. Okay, so remember that with a hexagon, we can draw in at least 6 different triangles. And so my central angle here would be 360 divided by 6, which is 60. And again, that means that if I divide it in half, that's 30. But I'm still working with a 30, 60, 90 triangle here. So if this is my 60, then my apothem, which I'm going to label it A, my apothem is going to be 2 square roots of 3, since this side is 2. And then that's all I need to find the area of the base, because we already found the perimeter up here. So area of the base is going to be 1/2 my apothem, 2 square roots of 3, times the perimeter, which is 24. And I have 24 square roots of 3 feet squared. Okay. Now volume is the question, so it's the area of the base times the height. So now I'm going to zoom out just a little bit. Area of the base we just found was 24 root 3 times the height, which is 10. Let's go ahead and leave this in exact form. So that would be 240 square roots of 3 feet cubed, because it's a volume. Oops, which means up here, caught my mistake, this volume has to be cubed. Alright, number 7. Alright, so the volume of a right cylinder is 200 pi centimeters cubed. We are given the height is 8 centimeters, find the diameter. So this one, sketch out a cylinder. So I'm going to draw the top first, draw the sides, and then sketch out the bottom. So here's the radius, which is r, and our height is given as 8, and we're given 8 centimeters. So we're given the volume to be 200 pi centimeters cubed. Okay. So to find the diameter, we must find the radius. Okay. Alright, so to find the radius, we need to use our formula. So volume is area of the base times the height. Luckily, we're given the height, so we can go ahead and say 200 pi is equal to pi r squared times the height. Okay? And because this is multiplication, if you remember from algebra, we can divide more than one term when it's all multiplication. So I'm going to divide by 8 pi on both sides. The pi's will cancel out to 1, and I have 25 is equal to r squared. And the radius, take the square root, that means the radius is 5. Can't be negative, so it's positive 5, right? Which means the diameter is equal to 10 centimeters. So the diameter is twice the length of the radius.